So now that you've had a chance to look at quadratic formula as a means of solving quadratic equations like this one, I want to add one more piece of terminology, and that's the so-called discriminant. The discriminant of this equation, ax squared plus bx plus c equals 0, is this portion of the quadratic formula which shows up underneath the square root. It's this portion of the quadratic formula, which is b squared minus 4 times a times c, the bit under the root. And so sometimes I'll recommend to students that if they're trying to use quadratic formula to solve a quadratic equation, that you calculate the discriminant on the side. Recommend. Calculate the discriminant first on the side, and then take negative b plus or minus the square root of the discriminant all over 2a. That just helps to get things, a little bit cleaner, not quite so overwhelming, and it's much easier to type something like this into the calculator, I would say, rather than trying to do something huge and hefty all at once. There is a second advantage, though, to calculating the discriminant separately before anything else, and that's sometimes, if you're lucky, you can escape the problem very quickly. You can be done with the problem very early if you calculate the discriminant first. And that's because of the following principle. Depending on whether the discriminant is positive, negative, or 0, the discriminant will tell you whether or not you have 2 solutions, you should expect 2 answers, whether you have 1 solution, or whether you have no solutions at all. So, if the discriminant is a positive number, and the plus square root and the negative square root of that number are different, then you have 2 solutions. 2 solutions to the equation. 2 different solutions. If the discriminant is 0 on the mark, then the square root of 0 is 0, and positive 0 and negative 0 are exactly the same thing. And because of that, your equation will only have 1 solution. The plus version from quadratic formula and the minus version from quadratic formula will work out to be exactly the same number. So they'll be redundant and there's only 1 solution. But if you're quite lucky, your discriminant will be negative. And if your discriminant is negative and you're trying to take the square root of a negative number, you're going to run into some trouble because there is no real number, which when you square it, you get a negative result. So if the discriminant is negative, you know for sure that your equation doesn't have any solutions if you're staying in the real numbers and not bringing I into the game, not bringing the imaginary numbers in. So if you find that your discriminant is negative, you can just jump right here and say, whoop, no solutions after all. So let's use that principle on an example like this one. Someone gives me the equation 3x squared plus b times x plus 4 equals 0. And the challenge is, can you find any value of b so that 3x squared plus bx plus 4 equals 0 has no solution? No solution. I know that this equation will have no solution if the discriminant is negative. So perhaps I can try and find a value of b that will make the discriminant negative. Now, for this equation, take a moment. We don't know the b value, but what is the a value? And what is the c value? Well, the a value, the coefficient of x squared, is 3, and the c value is 4. So let's put all that data in. Let's do a little bit of cleaning. B squared minus, I think this is 48 in the back, 4 times 3 times 4. If I can find any value of b, so that b squared minus 48 equals 0, I will have met this condition. Now, that I think is pretty easy to do. I could rewrite this just a little bit if it helps me think. Any number whose square is smaller than 48. So things that could work, for example, I could choose b to be 0. 0 squared is definitely smaller than 48. B could be 1. B could be 2. B could be 3. B could be 4 or 5. All of these numbers have squares that are smaller than 48. I think even 6 squared is smaller than 48. B could be any decimal number between these. There's nothing saying that B has to be a whole number. So you could be, if you're feeling a little perverse, you could choose B equals pi. Nothing's stopping you. You could choose B equals the square root of 3, if you like. Or B could be a negative number. Negative 1 squared, for example, is less than 48. In all of these cases, this equation would not have any solutions at all.